Good morning, my dear students. It is your Chemistry 1 class, and today our topic is strength of acid and base. Look, you know that the acid, hydrochloric acid, sulfuric acid, nitric acid, these are strong acid. But can you tell which acid is more stronger? Now, today we will learn about this strength of acid and base. The strength of acid depends on some factors. These factors are, at first, acid dissociation constant Ka. You know this, the more value of Ka, the acid is more strong. That means the acid which has more Ka value, it will be more strong acid. Now, size of negative ion of hydroacids. At first, you have to know what is hydroacids. There are two types of acids, hydroacids and oxo acids. Hydrogen is must for every acid, but if you look, you will see that most of the acids have oxygen also. The acids which have no oxygen atom with them are called hydroacids. For example, hydrochloric acid, hydrofluoric acid, hydrocyanic acid. Look, there is no oxygen. So these acids are called hydroacids. Now, at first we will determine the strength of these hydroacids. The strength of hydroacids depend on the size of negative ion. That means the negative ion which is joined with hydrogen ion. For example, chloride ion for hydrochloric acid, fluoride ion for hydrofluoric acid, etc. Now, if the size of negative ion is small, the acid will be weaker. Just you have to remember this. For hydroacids, if the size of the negative ion is small, the acid will be weaker. Now we can compare these four acids: hydrofluoric acid, hydrochloric acid, hydrobromic acid, and hydroiodic acid. Now in these four acids, fluoride ion, chloride ion, bromide ion, and iodide ions are negative ion. Here the size of fluoride ion is the smallest and iodide ion is the biggest. So the strength of these acids are, the most weak acid is hydrofluoric acid and the strongest acid is the hydroiodic acid. Now for oxyacids. Already I have told which are oxyacids. The strength of oxyacids depend on the oxidation number of the central atom of acid. What is central atom? For example, sulfur for sulfuric acid, nitrogen for nitric acid, phosphorus for phosphoric acid, and so on. Now, you have to look the oxidation number of this central atom. The oxidation number of the central atom, if it is more, then the acid will be more strong. Look, if the oxidation number of central atom of an acid is more, the acid will be more strong. For example, there are four acids. Everywhere the central atom is chlorine, but their oxidation number is not same. This is hypochlorous acid, where the oxidation number of chlorine is +1. This is chlorous acid. Here the oxidation number of chlorine is +3. Here +5 for chloric acid and +7 for perchloric acid. Look, since the oxidation number of chlorine is 7, chlorine is the highest for perchloric acid. So perchloric acid is the strongest acid. And among these four acids, hypochlorous acid is the weakest acid. Now here the central atom is same for these acids. But look, this is another example. Here the central atom is not same. This is sulfurous acid, where the oxidation number of sulfur is +4. This is nitric acid. The oxidation number of nitrogen is +5. Here sulfuric acid, oxidation number of sulfur is +6, and in perchloric acid, oxidation number of chlorine is +7. So among these 4 acids, the most strong acid is perchloric acid, then sulfuric acid, then nitric acid, and at last sulfurous acid. Now you will see there are some acids where the oxidation number is same. For example, phosphoric acid and nitric acid, where the oxidation number of phosphorus and nitrogen both are 5. Then how will you determine the strength of these acids? Now, if the oxidation number of the central atom is same for 2 or more acids, then you will see the size of the central atom. That means if the size of the central atom is small, then you know its electronegativity will be more. And if the electronegativity is more for the central atom of any acid, then this acid is stronger acid than other. Look, here there are some example. Nitric acid and phosphoric acid. Here both have oxidation number 5, nitrogen and phosphorus. But which one is the smallest? Nitrogen. And so the electronegativity of nitrogen is also less than phosphorus. For this why nitric acid is the stronger acid than phosphoric acid. Okay. Some more examples. Look. There are nitrous acid and phosphorus acid. Both nitrogen and phosphorus have oxidation number +3. But for the smaller size, nitrous acid is stronger than phosphorus acid. There are some acids, perchloric acid, perbromic acid, periodic acid. Here also, whose size is the smallest? Chlorine. So, chlorine has more electronegativity than bromine and iodine. So, their strength will be the most strong acid is perchloric acid, then perbromic acid, and at last periodic acid. Now, another factor is this nature of solvent. We know the acid is dissolved into water. That means we see the acid in aqueous solution. Here water acts as a solvent. Now when acid and water are there, acid donates its proton into water, and by accepting this proton, water acting as a base. But you know the tendency of accepting proton is less for water. Why? Because water is a weak base. So, the weak acid that is weak in water solution will be strong in a comparatively strong base solution. Look, here also the acid can ionize more in a solvent which has more power to accept proton or more basic. For example, acetic acid, it is weak acid in water solution, but it is a strong acid in ammonia solution. Now, the strength of base. The strength of base also depends on some factors, that are solubility of metal oxide and hydroxide in water. You know, the metal oxide or hydroxide, they are base, and if these metal oxides and hydroxides are soluble into water, or their dissolving capacity is more into water, then these metallic oxides or hydroxides are strong base. And if they are not dissolved into water properly, they are weak base. For example, sodium hydroxide. It is more soluble into water than magnesium hydroxide. So sodium hydroxide is stronger base than magnesium hydroxide. And another one, base dissociation constant. Here also the more value of Kb, that means if the base dissociation constant Kb value is more for any base, then the base will be more strong. Now, basicity of acid. What is basicity of acid? The number of mole of monoprotic or monoacidic base, that means the base which has one hydroxyl group. The number of mole of monoprotic or monoacidic base, sodium hydroxide, potassium hydroxide, is completely neutralized by 1 mole of acid is called the basicity of that acid. For example, sulfuric acid. Sulfuric acid is neutralized by 2 mole of monoprotic base, that is sodium hydroxide. So, the basicity of sulfuric acid is 2. Another one, for example, what is the basicity of HCl? To neutralize HCl, 1 mole sodium hydroxide is enough. So, the basicity of HCl is 1. And acidity of base. What is acidity of base? The number of mole of monoprotic or monobasic acid. Here also the acid which has only one hydrogen ion. Hydrochloric acid, nitric acid, these acids are called monoprotic acid. Is completely neutralized by 1 mole of base is called the acidity of that base. For example, what is the acidity of sodium hydroxide? To neutralize sodium hydroxide, 1 mole nitric acid or HCl is needed. So, the acidity of sodium hydroxide is 1. What is the acidity of magnesium hydroxide? Here, to neutralize magnesium hydroxide completely, 2 mole HCl is needed. So, the acidity of magnesium hydroxide is 2. Now, today up to this, here also some homework will be given. At first, compare the strength of acids. There are 4 acids: perchloric acid, sulfuric acid, nitric acid, phosphoric acid. Here, you have to use all the factors. And this is not short question. This is a broad question. So, broadly you will write this. And another one, that is calculate the acidity of aluminium oxide. These 2 are homework today up to this, and thank you everyone.